Okay, so jumping into 6.3, the next thing we need to do after we've learned how to multiply and divide these rational expressions is we're going to add and subtract rational expressions. So here's the steps. The first one is we need to fully factor the denominator of each expression. Then we're going to, just like we would in any other cases, state the non-permissible values in the denominators before adding or subtracting, because remember, we might wind up getting rid of some of those denominators. We still need to account for them. The next thing is we're going to figure out what our lowest common denominator is, because remember, when we are adding or subtracting fractions, we always need to put them over a common denominator. The same thing is going to be true with our rational expressions. Express each rational expression as an equivalent rational expression with the lowest common denominator, and then combine the rational numbers by adding or subtracting like terms across the numerator. And then, if it's at all possible, we're going to keep reducing like we did with the multiplying and dividing at the end. So always, 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 once you get to the end, see if you can reduce it further. We always want to keep our answers in factored form for the binomials. So don't worry about multiplying it out in the final form. It should still be factored down to show, no, there is no other common factors that exist. So let's try a few examples of this. For the first one, it says determine the sum or difference, express your answer in simplest form, identifying all non-permissible values. Well, I can't factor the denominators in here, which means that I can already find my non-permissible value. N cannot equal 0. There's my non-permissible. The second thing is I'm going to find what the common denominator is between these two. Well, they both already have an n, so I'm just looking at the coefficients, and the coefficients are 2 and 5. I'm going to say my lowest common denominator is going to equal 10n. They both have to have an n, and then the coefficients are going to have a common multiple of 10. So, in order to make them match, then I know that I need to multiply the top and the bottom of the first set by 5, and I need to multiply the top and the bottom of the second set by 2. This is going to give me a common denominator of, I'm going to have 5m over 10n minus 2m plus 2 over 10n. And then, because they have a common denominator, I can just say that this is going to be the same as 5m minus 2m plus 2 all over 10n. If I have 5m, I'm taking away 2m, then I'm left with 3m. And then the minus 2, all divided by 10n. I can't reduce that at all, so there's my answer. And I should state that there's my simplified answer, restating that n cannot equal 0 in this case. Okay, if we take a look at the second case, once again, I can't factor these any further, so I'm going to look, well, if I have 7 and 21, oh, actually, let's do our non-permissible values first. If I'm doing my non-permissible values, if I just have the t's here, just have the t's there, they're not binomials, so t just can't equal 0. If I have the 7 and the 21, the lowest common multiple of those for the denominator is going to be 21. If I have t to the 2 and t to the 3, then they all need to have at least 3 t's. Which means that the one on the right already has the lowest common denominator. The one on the left currently does not. Which means that here I'm going to have to multiply the top and the bottom of the first set by 3t. So what I'm actually going to have is I'm going to have 3 times 3t minus the 2 that was already up at the top all over 21 t to the power of 3. That's going to simplify to 9t minus 2 over 21 t to the power of 3. This can't be simplified any further. And I'm going to restate that t cannot equal 0. And there's my simplified expression. For example C, they're already factored, so I can state right from the get-go that m will not be able to equal 3 over 4. I can see that this one has 2 of the 4m minus 3's, this one has 3 of the 3m minus 3's, which means that my lowest common denominator is going to equal 4m minus 3 to the power of 3. So I need to multiply the top and the bottom of the first set by another 4m minus 3 to make them match. So what I can state is I actually have 2 times 4m minus 3 minus 8 minus 2m all over 4m minus 3 to the power of 3. This is going to give me 8m minus 6 minus 8 plus 2m over 4m minus 3 cubed, which would be the same as 10m minus 14 over 4m minus 3 cubed. And I can reduce this one to 2 and 5m minus 7. There's a factor form on the top over 4m minus 3 cubed. I can't simplify it any further. There is no common factor on the top and the bottom. And this is where m cannot equal 3 over 4. And there's my answer. Okay. For example D, they're all factored on the bottom, and I can see that x cannot equal either 1 or 3. I can see that for the denominator, they all have the x minus 3 and x minus 1. But for the coefficients, I have a coefficient of 1, of 2, and of 4. The lowest common multiple of those is going to be 4. So I'm going to say that the lowest common denominator is going to equal 4 x minus 3, x minus 1. Which means for the first one, I'm going to have to multiply the top and the bottom by 4. For the second one, I'm going to have to multiply the top and the bottom by 2. And the last one already has the lowest common denominator. So What I actually have here is 4 2x squared minus x minus, watch these signs in between, 2 and 3 plus 6x, and then plus 8, all over 4 x minus 3 x minus 1. This is going to give me 8x squared minus 4x minus 6 minus 12x plus 8 over 4x minus 3 x minus 1, or 8x squared minus 16x plus 2 over 4x minus 3 x minus 1. I'm going to factor the top and say that I can factor it by 2 and get 4x squared minus 8x plus 1 over that 4x minus 3 and x minus 1. Now, I can't factor down this trinomial at the top, but I can take a look here and I can see that, well, there's a common factor between the 2 and the 4. I'm going to divide the top and the bottom by 2. So I'm going to state that all of this is going to simplify to 4x squared minus 8x plus 1 over 2 x minus 3 x minus 1, where x cannot equal 1 or 3.